week's lab activity where we will go over coordinate systems and learn about projecting. So you should all be on week 4 homepage or overview page rather. And then if you scroll down to the lab activity, you will see an area to download the data under activities. And that link will take you to here where I've uploaded our Horton point data. And all you'll need to do is click download. And if you don't have access to this, please send me an email and I'll try to get you access right away, but you all should because you're within Cal Poly organization. So you click download. It downloads as a layer package and you can show folder. And then in here in the downloads folder, double click and it should open up an ArcPro project for you because I've saved it as a layer package already. You don't need to extract data and add it. It'll simply open as a project. And so today's lab activity, while this is loading, I'll go over it. Basically, a field crew mapped the Horton fire perimeter using GPS equipment during suppression operations. And now I know, and you probably all know, wildfires are normally mapped with some type of aircraft, but for today's lab activity, we had crew on the ground, and they were using a GPS device because it was a smaller fire and they were able to get lat and longs. Okay, and so because GPS devices record locations using the geographic coordinate systems, the fire perimeter was delivered in latitude and longitude information. Before the data can be incorporated into the agency's GIS database, you as a GIS tech are required to look at the data, inspect it, and make sure it can be projected into the fire agency's projected coordinate system that they use. And normally in an organization, you already know the PCS that the agency uses, or you would ask a coworker, or you'd maybe look it up online, or you reference other layers. So for today's lab activity, I'll just tell you that the Horton Fire is located near Payson, Arizona. So if we zoom out, you should be in Arizona. Zoom all the way out, and we are in Arizona. And based on this location and the need to calculate acreage, the coordinate system we will be using today is NAD 1983 State Plane, Arizona Central FIPS 0202. And I'll show you that in the lab activity. Okay, so let's begin. We can right click on GPS points, Horton Fire, and zoom to layer. The first thing we want to do is inspect the data. So let's right click on the layer and then scroll down and select properties. And you should see the layer properties window and you have different tabs. We want to go to the source tab and you could see metadata. If it's from like a CAL FIRE, for example, they would have a summary and description. But for today's lab activity, that we don't have any metadata. So go to source and then you could click the down arrow and you see data source, and then it goes away. Click the spatial reference. So you will always find coordinate system information in the spatial reference fields within the map properties window. And here you could see, like we've learned in lecture, that it has a geographic coordinate system of WGS 1984. So that means the data was collected in WGS 1984 coordinate system. Okay, so we know there's a mathematical model that goes behind this and lots of math. And now it's needing to be projected because there is no projected coordinate system. If there were, you'd see a box under here and it would say projected coordinate system. So right now we're looking at a GCS of WGS 1984 angular units of degrees. And then it shows the datum and the spheroid, which we've learned about in lecture, and then some additional information, which we aren't going to get into in this class. Okay, so at least it's good that we have this information and that the data looks good. We could also take a look at the attribute table. So right click on the layer, select attribute table, and a lot of it's null. That's unfortunate, but at least we have the geographic information, which if we scroll all the way to the right, it should show lats and longitude. And that's really all we need for today's lab because the objective is to create a fire perimeter map. And so this is, as you can notice, this is a point feature class. And you can't calculate area of a point, right? It needs to be a polygon. So a couple things are going on here. We just have straight XY data, latitude, longitude, and it's plotted, and they made a point feature class, which is great. But we need to project it, so give it a projected coordinate system so that we can calculate the area in linear feet or a different type of measurement. And we also need to use some geoprocessing tools to create a polygon from this data. At this point in the lab, you can fill out the table from the lab submittal page, which has information about the layer. Okay, so the first thing we want to do is project this geographic coordinate system into a projected coordinate system. So to do that, we are going to have to use a tool. So go up to the analysis ribbon and select tools. And I'll make this wider and then type in project. And they always give a description of the tool so you could be sure you're selecting the right one. We don't have raster, this is a vector data. So click project and you'll have prompts. And the first drop down should be the layer that we have in the map, GPS points, Horton Fire. And it automatically grabs the input coordinate system, which is correct. It's WGS 1984. Output data set or feature class, I'm going to just leave as is. You can save it anywhere in your geodatabase you'd like. Right now, I didn't actually save a new project, and I don't think you need to for this lab activity unless you'd like to for future reference. I'll keep the default. And then output coordinate system, we want to select this globe icon, and we're going to choose the projected coordinate system. So select the drop down. And like we learned in lecture, there are a ton of projections. We want to use what the agency requires, which is NAD 1983 state plane. So it's a state plane. Arizona, which typically we use California for SLO data. Like when I worked at the city of SLO and now the county of SLO, we use state plane California. We're going to use We want to use NAD 1983 US feet, state plane, Arizona, central FIPS 0202, this one. And you can also copy and paste it right here into the search bar. And it's nice too, because you can press this little star icon, right click and say add to favorites. So if you're going to add more layers, create more feature classes in this project, it'll just be in the favorites tab, which is really helpful. So I'll add it to favorites. And then if I scroll up under favorites, it's should be right there, which is nice. So then select OK. So the geographic transformation is WGS 1984 to NAD 1983 state plane, Arizona. And then select run. Okay, and it's already completed. You could see the details of the geoprocessing tool. We're going to click out of here now. We don't need to run it again. And my question for you is, do you see a difference? We could change the symbology of the project layer, and let's make it, instead of brown, we'll make it a different color so we could tell. I'm going to change the color to red. Okay, apply. And I see that they are overlapping. They're almost identical. So if you turn the project layer off back to the brown, they look identical, right? Well, that's because Arc Pro, especially the updated versions, use something called on-the-fly projection. So basically it tries to project knowing its location on the fly, quote unquote. And yes, to the naked eye, it looks good, but it's always good to have that projected coordinate system in the actual data. And to check now, let's right click our layer and select properties. And again, go to source. Remember, we didn't look at data source, but we looked at spatial reference. And this is where we're going to see, hopefully, the projected coordinate system. Ah, there it is. Projected coordinate system. It's the correct one the agency uses. The projection itself is transverse Mercator. WKID, I went over in lecture. It's like a unique identifier. And then you could see there it doesn't use angular units. Rather, it uses a linear unit, and it's US survey feet. So now we can actually make measurements in feet. And then if you keep scrolling down, you'll see it has the geographic coordinate system, which is NAD 1983. And you can see that it's NAD 1983 instead of the WGS 1984, and that's because the project tool converted the data into a projected coordinate system that is based on the NAD 1983 GCS. So it's doing what it should be. I don't want to get bogged down by this. I just want to point that out, that it's all part of the tool and converting the GCS to the underlying GCS for this projection. Okay, so that all looks good, and we can select OK. And now you can continue to fill out this table that was provided in the lab submittal. Back these two layers a little bit more so we really understand the difference in the coordinate systems. So I have opened the original layer, GPS points _ Horton Fire, and I'm going to just select any point. You could select the same one as me if you'd like. I use the select tool in the map ribbon, and then I come over to the selection icon, and it's object ID 273, and scroll all the way to the right, and let's look at the lat long. We have latitude -111.0876 and longitude is 34.3273. Okay, but then I want to see what it says for the new projected layer. So let's right click the projected layer and select attribute table. And here's another trick in ArcPro, which I've always used, is right click the layer that you want to select. You see how it selected the original layer, the brown point. I want to select the red one out of this table. So you right click on the Horton Fire _ project and then say selection. Make this the only selectable layer. Okay. So now I'm just going to, I got to have my select tool on. So choose select, and it should select one from the GPS points Horton Fire _ project. So go to the selection icon, same object ID, scroll all the way to the right, and what kind of data do we have? We have latitude and longitude. And that's because it still stores the same attribute data, which is nice. It didn't overwrite it, it didn't change it. And although lat and longs aren't used in this projected layer in the underlying data, it still has it as an attribute field. But let's go ahead and create a new field so we can see the new XY data. So in the project layer, we're going to select feature layer. Nope. Go to table rather, and then select fields. And we've done this in lab before. I'm going to make this bigger. And there's so many fields in this layer. If I were a GIS tech, I would clean this up. But for today's lab activity, we're just going to go all the way to the bottom, create a new field and call it X. And let's make the data type double. Okay, add another field and select type Y, and again make it a double, and then select save. And so your new fields have saved, so you can click out of the fields table, and then all the way to the right you should see your new fields X and Y. And you could run this, what we're about to do, on all of them. So you could clear selection, so go up to the map ribbon and then press this clear icon, and it now it'll, if you go back to the attribute table, it'll show all the fields, all the records rather. Okay, scroll all the way to the right, right click on the X field and select calculate geometry. Okay, here the tool pops up and it's going to ask for parameters. So for the input features, we're going to keep this selected as is, the project layer. And then for the X field, we want point X coordinate. For the Y field, we want point y coordinate. And now that we've projected our GPS points into a projected coordinate system, we want to now calculate the x and y coordinates for each point in this new projection. And so you'll notice there's a setting called coordinate format. This can be a little misleading. The options, if you select the down arrow, are decimal degrees, degree, minutes, seconds, so on. And they're formats for displaying geographic coordinates, not different coordinate systems. So I just wanted to point that out. Since our projected layer is already stored in NAD 1983, State Plane, Arizona, Central, we're going to leave this to same as input. That tells the system to calculate the coordinates using the layer's existing coordinate system. Okay, and then the coordinate system we want is the projection, which is NAD 1983. It's a state plane. Okay, and then select OK. And then scroll all the way to the right. And so after running the tool, you'll see that the new X and Y fields contain values around 958,000, 610, 900. So it's around 958,000 and then over 1 million for the Y. These are not decimal degrees, which maybe you thought at first. If these were latitude and longitudinal values, we'd expect numbers closer to like these, negative 111 and 34. So instead, these numbers are state plane coordinates measured in US survey feet. So the reason they look different is because projected coordinate systems measure locations using linear distances from a defined origin rather than angular measurements on the Earth's surface. So that's why these lat and longs and these X and Y values look so different, because they were using different coordinate systems. And that's why these ones are still saved in this table because they're saved as an attribute and they'll never get like overwritten unless we overwrite them. And that's why you now have both the original geographic coordinates and the new projected X and Y coordinates in the same attribute table. So I just wanted to demonstrate that. Okay, so now we understand the difference in GCS versus PCS, how they're different angular and units of measurements. They're used differently, and some other characteristics that are different. And so we can go ahead and close these layers. And now we want to focus on finalizing this fire perimeter map. Now that the data looks good, we've projected it. We can even remove this one, okay, completely from our map and keep it simple. And we want to now run another tool that will convert these points to a line and then to a polygon. So go to Analysis, Tools, and then do point to, we want to do point to line. And so I was hoping it would show up, but we'll do point to line. Okay, and then select Data Management. It's the second one. And the input features is the only layer now in the map. The output feature class we could just keep as is. It'll save in the default geodatabase, which was the created and saved geodatabase when we started this map. The line field we will leave blank, and then the sort field we will choose object ID. Now for sorting, it's going to use the object ID of the points and connect 1, 2, 3, 4, so on and so forth until the last endpoint, which in this case is, I believe, 279. In a normal situation, you'd want to make sure that each object ID goes in order. However, I do know that some of these are not in order. So this is object ID 1, and you'd think that 2 would be here and then 3, but you could see it goes the opposite way, and then it starts with 10. So it's going to show up a little funky, and I'll show you why that is. So if you were following along with me, you could select clear selection and continue with the points to line. Line field empty, object ID, select close line, construct continuous line, and then none, and select run. And so now we're connecting the points to create a line feature class, which it just did. And here is where the data, underlying data, is a little not accurate when they collected the GPS waypoints. So it's going to show this hop to the next object ID. For today's lab, we're just going to continue because I don't want to make this about correcting underlying data, rather just using geoprocessing tools to continue to create an area or a polygon. Okay, so then let's look for the next set of tools. You could zoom out and see your new layer. It's turn off the point feature class. You've now created a line feature class. And then we're going to go up to analysis tools and now select line to polygon. Oops. Oh, actually, it's now called feature to polygon. Sorry. Sometimes the tools change as different upgrades happen. So feature to polygon, go ahead and select that tool. Make the input feature the points to line. So that's the line feature class. And then the output, we're going to keep the default, which we want feature to polygon. We could rename for the final map. And then for label features, we're just going to keep blank and then select run. And just like that, we've created our fire polygon data of the perimeter. And so I know this lab was mostly focused on coordinate systems and looking at the coordinate systems of different layers and different data, but I wanted to finish up this lab activity with a final map of a polygon. So you could turn off the other layers and you could see that the properties of this polygon should be a projected coordinate system. Go to spatial reference, and it's the NAD 1983 State Plane, Arizona. And then to finish off this lab activity, you can calculate the geometry of this entire burn. So to do that, right click on the layer, select attribute table. And there are two polygons, it looks like, the one of the mess up there and the one of the total. For the mess up, where the object ID was out of order, we can actually delete this. And so make sure you're selecting the inaccurate data and then select delete. Okay. And you can clean this up by editing the polygon. Go to the edit ribbon, modify, and you've digitized before, so this should be review, but you just want to make it look presentable at the perspective that you're going to be at. So you can select edit vertices and then play around. Feel free to play around. You can kind of move the points, delete a couple points, right click, delete vertex. You just want to close that polygon. So move the vertices around. Don't be afraid. You know, if you move some and then you click out here and that doesn't look good, that's okay. Click back in. And I'm just actually going to delete these vertex. Because our audience is simply wanting to see the perimeter of the fire data, it's okay to delete these GPS points for this purpose. So it's always important to think about your audience, think about the purpose of your map. You don't want to be deleting GPS points that have turned into points if you're going to be sending that data to someone. But for today's lab, this is fine. And then select save, edit, save edits. And we want to be able to calculate the geometry. So now you should only have one record. The shape area, you could right click. Oops, the shape area is a defaulted attribute. So we actually want to make our own new field. So up in the tables ribbon, select fields, and then select area. You could select double. Oh, and you may see that the save button is currently disabled due to unsaved edits. Save or discard those edits. We want to save those edits. So it won't let you create and save a new field unless you save your edits. Okay, so then area, save. click out of there, and our new field should pop up, and right click on the area field and calculate geometry. And then the area we want acres. Sorry, the property should be area, and then area unit, we want it to be in acres. US survey acres. Coordinate system, it should be the same as the polygon. All three of these are the same, so either one. And then select OK. And there is our area, 8,327.94 acres. So the objective of today is to symbolize your fire and then label the acres and create a final map. You could change the symbology. This is review. So right click symbology. Click on the rectangle. Let's see what they have in the gallery. We could do a dashed line. And maybe we want to make it red instead of black. Apply. And then also this is review is labeling. So label your polygon, and it's using the field shape length, which we don't want. So right click labeling properties. I'm going fast. You could feel free to pause, or if this is review, you could skip this since you all should know how to label by now. But I will just do it in case you need a reminder. So instead of shape length, we want area. And then we want to add plus acres. Oh, let's add a space, apply. And we don't want all these decimals. So again, we do that in the actual attribute table field, right click. It's, actually we want to right click, click up to table, select fields, and scroll down to the area. And then the number format is numeric, double click, and then click on these horizontal dots, and then decimal places, let's go to 2. And then save. And once it saves, it should reflect on the map. Let's see. Maybe if I zoom in and out. Oh, that's odd. Let's see. Maybe if I turn it on and off. So I just remembered that the arcade language actually takes in the value in the underlying data, whereas the attribute table rounds it to the 2 decimal places. So we have to tell the system to round it. So let's put parentheses around the feature.area. And then in those parentheses, we're going to do comma 2. And at the beginning, we'll say round. I think I need to go the different parentheses. Yeah, the parentheses are in the wrong spot. Sorry. It should be like this. Now you can green check to verify and then apply. There you go. And that's how you round it. You could change the label, font, format, color. But then now that you have your map looking the way you want, you could insert a layout, 8.5 by 11, and make sure you include your final layer, the projected area, which is the polygon. And so we're going to insert a map. So within your layout, we want a map frame. And a quick trick is to right click on your layer and select zoom to layer. And that creates a nice perspective of the fire. And then you can insert your 5 essential map elements. So your north arrow, I like to add a add guide, and this helps you with aligning your elements. You insert a scale bar. Make sure they're rounded whole numbers and applicable, like instead of 0.5, if you have like 0.17, try to rearrange that so it's a little more relatable. Your legend. And then we're going to change that layer name because that doesn't make sense to your audience. So up in the legend, you don't need to have any of these because they're not even in the map, but you can. And sorry, this is so zoomed out. You want to change the layer name. So you do this a couple ways. You can, you could click and hold, and that should allow you to change it. Sometimes it's a little finicky like that. Or you can right click properties, and in general, you could select Horton Fire. Okay. And then maybe we'll also say Arizona. Okay, and that should reflect, oh, I spelled Arizona wrong. Always double check your elements on your map. And then we also need a title. Horton Fire, Arizona. Oops. It's so small, so now I'm going to change the format. Text symbol. I want it to be much bigger. And then we'll add the author and date in the bottom right. You could do author, Noel Frempter, and then your date. Okay. And for having this much white space, you can even put the legend down here so it pops more. And then adjust your label and symbology so that it clearly shows up to whatever scale you're working at. And that should conclude your lab activity. I hope you learned a little something today about coordinate systems, even using geoprocessing tools, and I will see you later in the week. Thanks.